like probably the last video on this, and we're just gonna just grab random questions that I saw from online sources, and a lot of questions that maybe some of my students have actually emailed me. So this first one says, which statements? Okay, so these being the statements down here, there's 1, 2, 3, 4, 5. Okay. Oh, that's really hurting my eyes. Okay, so which statement? Oh, that's really hurting my eyes. Yeah, no way. I don't know why, but these are the choices. Which statements are true about the graph of y is less than or equal to 3x plus 1 and y is greater than or equal to negative x plus 2? And they gave us no graph. So check all that apply. So we can't even graph this right now. So let's go through them. The slope of one boundary line is at 2. The slope of one boundary line is at 2. Okay, so what is the slope of these guys? Okay, well, let's see. Do you remember what this is? This is your y-intercept, right? So these are the y-intercepts. Okay, this right here, what's the slope there, right? M means slope, so what's the slope? It's gonna be -1, but we're also gonna put it over 1. And this right here, the slope right here is 3, or 3 over 1. Okay, so this is definitely not right. Both boundary lines are solid. A boundary line, in case you were wondering, I'm not too sure if I had spoken about that, is that when you graph a line, you can either have this right here or you can have this. So these are called boundary lines. And the reason why they're called that is because depending on how you're shading, so let's say that I was shading like this, okay, this is the boundary or the line, the portion or the section that it does not cross. That's a boundary. So that's what they were. And they're saying that both the boundary lines are solid. Well, we can easily identify that by looking right there. Okay, this is going to be a solid line because it has an easy way to think about it is that it has a solid line on the bottom, so I think of it as a solid line. This right here, solid line as well. So this is a definite, yeah, that's a check marker there. Let's put that on this side. A solution to the system is 1 comma 3. All right, so that looks like we might have to do some math. Now, if we were graphing this, we can literally just go to the coordinate and look at it and be like, yeah, definitely, or no, definitely not. But there's no graph, so we can't actually graph this. So we're gonna skip this. This looks like it might be math involved. Okay, both inequalities are shaded below. Okay, so if you again, we can just go back to the inequality. This is a less than, so this would have been shaded below for less than. This is a greater than, so then this would have been shaded above, meaning that this is not a solution. Okay, well, this is not one of the things that we're gonna apply. The boundary lines intersect. Okay, so the boundary lines intersect. Let's think about that. We can sketch a graph, and I know sketching is a little bit hard, but I want you to like think about this. All right, try to sketch it. That means we start at 1. Okay, then we go up by like 3 and go over 1, right? Up by 3, go over 1. And I know the sketching is not going to be perfect, right? It's definitely not going to be perfect, but you can kind of have an idea if you were to do it. And then this would be a +2, okay, +2, and this would be going down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, and you kind of get a line that looks like this. Now, the more mathematical way to do it is that the only lines that never intersect, or what kind of lines, are parallel lines. And we know that they're parallel lines if they have the same slope. Okay, so if we look here, is the slopes the same? Okay, this is really a 1. Absolutely not. So if they're not the same, that means that they have to intersect at some point. So that's going to be a definite check mark there. Okay, and is it a solution? Is it a solution? The way that we're going to do this is, do you remember what a solution was? A solution is this. A solution is a coordinate or an ordered pair, okay, an ordered pair that makes all, okay, and in this case there's just two, all the inequalities true. Incredibly important. That's why I wrote it in like font 200. Okay, they have to be true. So we're going to erase this piece now, and I'll do this in a black color. And I'm going to write this down here. Y is less than or equal to 3x plus 1. And we'll draw a straight line coming down, and we'll do y is greater than or equal to negative x plus 2. And here's what we're going to do. That coordinate that they gave us, 1 comma 3, we are going to substitute this into each one. So this is our x and y, this is our x and y, right? So let's go ahead and substitute this. Y, in this case, y is 3 less than or equal to 3. See that x right there? I'm going to replace it with this 1 by using a parentheses, and then add the 1 at the end. So is it true that 3 is less than 3 plus 1, or is it true that 3 is less than or equal to 4? That is true. Okay. Now, just because it's true for one of them doesn't really mean anything. They have to be true for both of them. So here we have is y. I'm sorry about that, because y is not going to actually be that. We have is 3, because y is 3, greater than or equal to negative. Okay. Now notice I'm putting the negative, and then I'll put parentheses to fill in the x, plus 2. So 3 is greater than or equal to negative 1 when I distribute, plus 2. And negative 1 plus 2 is 1. Is it true that 3 is greater than or equal to 1? This is also true, meaning that this is going to be a solution. Okay, so these are the ones that would be true. Now, this is the only time that this would be a solution when both of them are true. Okay, it's not like one or the other or none. They both have to be there. Okay, so let's see what this says now. Again, it looks like they gave us a lot of things here. So it says Mr. Hernandez plotted the point 1 comma 1, so I'm guessing that's what this is, 1 comma 1, right? 1 and 1 on Hans graph of y is less than or equal to 1/2 x plus 2. He instructed Han to add a second inequality to the graph that would include the solution 1 comma 1. Which equation could Miguel write? So let's think about this. All right, now I want you to, now instead of just guessing this, it says that we want to add a second inequality. Second inequality means one of these guys, so that when you were to graph it, okay, you're going to also include the solution. So it means if I graph it this way, we want to get something that includes that. Okay, if I were to graph it a different way, let's say we go this way, we still want to have it shading down. So we have this piece here. If we were to graph this, let's say 2x plus 1, right? So we would start at 1, we'd go up by 2, right 1, up by 2, right 1. Same thing going down by 2, left 1, down by 2, left 1. And if we were to graph this, and we're going to take the time to graph this, okay? It is a dashed line, which we should know by now from the last couple of videos. And this would be a greater than sign, so we're shading this way. And you'll see that we don't get the solution, so this is not going to be the correct one that we would need. Okay, so we'll go ahead and just take this right off. We don't need that there. See ya. All right. Okay, what about another one? Less than 2x plus 1. Okay, and you know, actually, I'm going to actually put that back. Oh, I can't put that back. Awesome. All right, well, you know, it is what it is. Hold on, let me go ahead and just write this back. So this was a dash line, right? All right, so we had said that it can't be greater than. Could it have been less than the 2x plus 1? Do we have that here? We have greater than or equal to, so then no, there wouldn't have been any of those lines. All right, so then it has to be less than then. So 2x minus 1, start here, up to right 1, up to right 1, up to right 1, oop, peace out, and then down to left 1. So I'm actually graphing this guy right here, down to left 1, okay? We said it couldn't have been this one, right? And we also said that it couldn't have been this one. Notice that they just differ by that. These are going. Okay, these are exactly the same. Look at these. These are exactly the same, except that they have a different inequality sign. So one of them is going to be a dash line, and one of them is going to be a solid line, dash, and this would be solid, right? So, but then how do you know? It goes right through 1 comma 1. So which one is true? So here's what I want us to do. Okay, just we're gonna just take the time and just plug it in so you can really understand the difference. And it's such a small difference. Okay, so we're gonna plug in 1 comma 1. Okay, whoops, all right, We're going to plug in 1 comma 1. Where's my thing? This is your x and y. So every time you see a y, I'm putting in a 1. Every time you see an x, using a parentheses here, we're putting in a 1. And is it true that 1 is less than 1? Nope, it's not true. It's actually false. That's false. So that's not true. If you put it here now, is 1 less than or equal to 2 times 1 minus 1? Well, 1 is certainly less than 2. And is it less than or equal to 2 minus 1? Oh, I look at that, I messed up. It's 1 less than or equal to 1, right? It's not less than 1, but it is equal to 1. So that means that a solid line is the one that we really needed, and that is going to help us make our solution. Okay. I believe that's really all I wanted to do. I don't think I really need to do anything else. Yeah, no, that's something else. So that's pretty much it. And I hope that you understand how to do solving systems. The next thing that we're going to move into is modeling with real life scenarios. That can be a little bit challenging. So I'll see you then.